Welcome back to Dilemma's Concepts. In this video, we're looking at Algebra 1. All right, so it says here, what is the product of the expression? Here is the expression. The expression is 3x plus 6 squared. When something is squared, it is multiplied by itself. A quick way to multiply a binomial is to square the terms inside, all right? And then a quick way of squaring a binomial is to do this. We're going to square the first term. So 3, so this is 3x squared. It's going to give us 9x squared. You're going to square the last term. So it is 6 times 6, and that's 36. And for the term in the middle, you're going to multiply these and then double. So 3x times 6 is 18x. And when you double that, you get 36x. So this is the response we're looking for. So the answer right here is D. All right. All right. So let's get to the next question. So in the next question, it says, what is the product of the following expression? So we're going to distribute 2x. We're going to distribute 2x to all of these terms, and then we see what we have. For example, 2x times x to the second will give us 2, but x raised to the third. 2x times x will give us 2 and x squared. 2x times negative 5 will give us negative 10x. And if we see this, we're good. Here it is. My answer is D. Let's take a look. Another question. Which of the following, it says, which is the simplified form of the expression? So basically, I'm going to multiply my binomials there. So I'm going to have 2 times x. So that's going to give me 2x to the second power. 2x times negative 6, that's negative 12x. And then we're going to have 3 times x, that's positive 3x. 3 times negative 6, that's negative 18, and we're writing back. So what I'm going to do with these, I'm going to try to put these under the right headings, all right? So basically, this is 2x squared minus 9x, and that's the negative 12x and the positive 3 minus 18. Now I'm going to put this negative 2x squared there. I'm going to put positive 3x here. I'm going to put positive 30 here. And as you could see, this becomes 0, negative 6x, and this part here becomes positive 12. So I'm looking for negative 6x plus 12, and it's right here. Well, the next question, we're looking at an idea here. So in the diagram at the right, the dimensions of a large rectangle is 3x minus 1 by 3x plus 7 units. The dimension of the cutout rectangle is given as follows: x by 2x plus 5, as you could see in this diagram. The question is, which choice express the area of the shaded region? Concept, the shaded region here, um, the shaded region will be this. It's going to be the area of the larger rectangle. And we're going to minus the area of the cutout rectangle. All right, so the area of the large triangle is going to be the length times the width. So we're going to have to take, so let's just take our time and put this together. The larger rectangle. The area of that is going to be 3x minus 1 times 3x plus 7. So we're going to file this out. So 3x times 3x is going to give me 9x to the second. 3x times 7 will give me positive 21x. Negative 1 times 3x is minus 3x. Negative 1 times 7 is minus 7. When you simplify this, you have 9x squared plus 18x with a minus 7. Now we want to find the area of the cutout rectangle. All right, so the area of the cutout rectangle, let me put it closer here. So we're dealing with the cutout rectangle. So it's going to be x into 2x plus 5. So when you distribute here, we're going to get 2x to the second. Distribute the x here, we get plus 5x. I'm going to subtract. So what am I going to subtract? I'm going to subtract, it's minus 2x squared. I'm going to subtract 5. We're subtracting this one. So basically, we're going to have 7x to the second, positive 13x, and there's a negative 7 again. So we're looking for this, and it's right here. All right, so here what we have is, given that ax squared plus bx plus c is equal to 2, open bracket, 1.2x plus 0.5 plus 0.3 x into x minus 0.5 and so on. Basically, if we're going to find values of a, b, and c, we're going to have to work out everything on this side, and then we link corresponding, or what we call equating coefficients. So let us work out the right side, okay? So let us start with our distribution. 2 times 1.2x is going to give 2.4x. 2 times 0.3 will give us positive 0.6. And then now this must be used to multiply by 3. My bad, it must be used to multiply by x minus 0.5. All right, so let us multiply this. So we're going to have 2.4x times x. So it's going to be 2.4x, but now to the second. 2.4x times negative half is going to give us negative, but 1.2x. 0.6 times x is going to give us positive 0.6x. 0.6 times negative 0.5, that's going to give us a negative 0.3. We're still putting together before we link these. So let us simplify this. We do have 2.4, well, x to the second. When these combine, I'm going to get a negative 0.6x. So that's negative 1.2x plus 0.6x. And then I'm having a 0.3. I'm going to put these now at the appropriate place. So we have a 0.5, so we have a 0.5x squared. We're going to be adding that. We have a positive 2.5x. We also have a negative 1.3. If you put it together, we're going to have, when we add these two here, we're going to have 2.9x to the second. So that's that. When we add these, but this is negative, it's going to go down to positive. So it's going to be positive 1.9x. And these two negatives being added will give negative 1.6. So what we're about to do is to take this. So let me clear this off the screen. So what we want to do is we're going to take what we had here, which is ax squared plus bx plus c equal. Now let us focus on some quick ideas. As you could see here, this term is this term. We're seeing that. So definitely we could link there. We're saying a x squared is equated to 2.9x squared. This is the reason why I'm doing this, because there is an equal sign between the two sets of expressions. And so we're linking the corresponding variables like x squared with x squared. And then bx is equal to 1.9 with the x. And the term without any x attached to it will link to that term. So we could see from this, you could cross off your x. You could see that a is 2.9. From this, if you cross off your x again, we get in b is 1.9. I should have said x squared here. And then the c is negative 1.6. So basically, that's the way forward as we go. Let's go to the next question. Under what operation is the system of polynomial not closed? It's going to be under division. What do we mean by not closed? If you should put together two polynomials, would it give you back a polynomial? That's when it is closed. So if I add, for example, if I add x squared, like 3x squared plus 2x squared, I'll end up with 5x squared. This is still a polynomial, so this is good. If I subtract, we're going to still get the polynomial. If I multiply, I get more. But if I divide, I don't necessarily will get a polynomial. And the reason for that is, what if I divide x by x to the second? I'm going to end up with 1 over x. This, my friend, is not a polynomial. All right? So let us say it's under division. We don't necessarily will get back a polynomial. Let's jump to another question before we, you know. All right, let's read this one. So in this question here, what we do have is that there are 60, we want to underline. So there are 60 students going on a field trip to chocolate factory. The students are from 3 different classes. So we have Mr. Hooper with 24. We have Mr. Gomez, Mrs. Hooper, Mr. Gomez with 18. And then it says which of the inequalities correctly describe the students that could be used to solve for how many students are from Mr. Anderson. In other words, there are 3 teachers, we got 2 of them, and we want to know what could we put together to find Mr. Anderson's, given that Mr. Anderson represent that by A. There's 60, so whatever we do, it has to come up to 60. 18 students from one class plus 24 from another, plus the ones that we didn't get from Mr. Anderson should have to give 60. This can work, and if we see that, it's right here. So definitely we would use that to go forward. Now for this question, it says the ages of 3 friends are consecutive years apart. So consecutive means one after the other, this year, last year, next year, stuff like that. Together their ages come to 48, which it can be used to find the age of each friend. Now, where A is the youngest. So if A is the youngest, we're saying that A, that's the youngest. The other friend will be A plus 1. The other friend will be A plus 2. So you could see consecutive years there, and it's 3 of them. This age would have added to give 48. So we're looking for anything like this, and it matches this right here. A plus 1, A plus 2 gives 48. Now it is saying, what are the ages of the friends? So we want to solve this that we have. So if we put together our A's, we're going to have 3A. Put together our constant here, we have plus 3, and this is equal to 48. Now, as you could see, if we subtract the 3 from both sides, we're going to have 3. We're going to have 3A is equal to 45. And you could see that, okay? So if we divide both sides by 3, then A is 15. This is the youngest. So we're talking about having a 15, then a 16, then a 17, because they are just 1 year apart from each other right there as we go, all right? All right, let's take a look at this question here. So this question says here, student county is renting a tent for 350 for an upcoming student fair. Each student attending the fair will pay $0.5 or 50 cents then basically. All other attendees will pay $2.25. If 200 students attend, which inequality can be used to determine the number of attendees? Now, here's the thing. We're certain that there are 200 students. They're paying 50 cents. So 200 students will definitely go at 50 cents a piece. All right. This, all right. So that plus $2.25 times the number of attendees this must be greater than, or at least it's equal to 350. So this is the idea we're looking for. So it is right here. All right, so that is just a quick walk with some ideas in Algebra 1. See you next time. Like, share, and drop a comment in the videos. Bye-bye.